All right, let's talk about something that trips up so many developers when they first jump into Swift, especially if they're coming from a language like C++ or Python. I'm talking about inheritance. Today, we're going to unpack Swift's really intentional and frankly very clever approach to how our objects get their powers.
So let's get right into it. We're going to frame this whole explainer around one simple question that really cuts to the heart of the matter.
And here it is. This is the big one. If you've worked with other object-oriented languages, this is probably one of the first things you've wondered. Can a single class in Swift inherit from 2, 3, or even more parent classes all at the same time?
The short answer? Nope, absolutely not. A class in Swift gets one and only one direct superclass. Now, I know what you might be thinking. That sounds like a major limitation, right? Well, just stick with me here.
Because you see, that no isn't a bug, it's a feature. It's a really smart design choice that actually unlocks a much safer, more flexible, and I would argue a way more powerful way to write your code.
So to really get why Swift does this, we have to talk about a classic, infamous headache in programming that multiple inheritance can cause. It's known as the diamond problem.
First off, just to make sure we're all on the same page, what even is multiple inheritance? Well, it's pretty much what it sounds like. It's this idea that one class can draw its DNA, its methods and properties from more than one parent class at once, trying to combine all their functionality.
And this is where things get messy. This is the trap. So imagine you have a base class. That's step one. Then step two, you have two separate classes that both inherit from that one base class. Still with me? Okay, now for step three, you try to create a new final class that inherits from both of those middle classes. You can kind of see the diamond shape it forms, right? And that's where you hit step four, conflict. What happens if both of those parent classes have a method with the exact same name? Which one does the final class use? The compiler has no idea. This ambiguity is the diamond problem, and it can lead to some seriously unpredictable bugs.
And that right there, that's the whole reason. That's why Swift's designers said, you know what, we're just not going to do that. They chose to completely sidestep this problem to keep the language safe and predictable. It was a core design goal from day one.
Okay, so if Swift avoids that whole mess, what does it offer instead? Well, it turns out it's an incredibly elegant solution that's all about something called composition.
This slide is the key to the whole Swift philosophy. Think of it like this. Traditional class inheritance is all about an is-a relationship. A corgi is a dog. It defines its core identity, and it's a pretty rigid hierarchy. But Swift leans heavily on a different idea, protocols. And protocols are all about a has-a or a can-do capability. It's not about what something is, it's about what it can do. So while a class can only be one thing, it can certainly do many, many things. We're shifting from that rigid family tree to a flexible toolbox of skills. And to make all this happen, Swift gives us this fantastic toolkit. At the center of it all are protocols. Think of them as blueprints for capabilities. They say what something should be able to do. Then you've got protocol extensions, which are awesome because they let you provide default code for those blueprints. And this all leads to this beautiful concept of composition, building complex objects by just snapping together these smaller, focused capabilities, like Lego bricks.
All right, that's enough theory. Let's make this way more concrete and see how it actually works in the real world. Let's build a Tesla.
So here's the goal. We want to model a car, a Tesla, that obviously functions as a vehicle but also has these very distinct capabilities. It needs to be electric, and it needs to be able to drive itself.
So, these are our building blocks. First, we have one single base class, vehicle. This establishes the is-a relationship. A Tesla is a vehicle. Simple. Then we define our capabilities using protocols. We'll have an electric protocol that describes what it means to be electric. It can charge. And we'll have a self-driving protocol. It can engage in autopilot.
And now, check this out. This is how we put it all together. Look how clean and readable that is. Our Tesla class inherits from its one superclass, vehicle, and then it simply adopts or conforms to the electric and self-driving protocols. One identity, multiple capabilities. It's that easy.
So when we actually use this Tesla object, there's zero confusion about where its functionality is coming from. If we call a start method, we know that comes directly from its identity as a vehicle. If we call a charge method, that's guaranteed by the electric protocol. And if we call auto drive, well, that's required by the self-driving protocol. We get all the behaviors we want from multiple sources with absolutely no conflict.
So, now that we've seen the problem and Swift's really elegant solution in action, let's wrap this up and boil it all down. What is the key takeaway here? What is the core Swift philosophy?
If you remember just one thing from this whole explainer, please let it be this phrase. This is the modern, powerful pattern that Swift encourages. Single-class inheritance for what an object is, plus multiple protocol conformance for what an object can do. That is the magic formula.
And why does this matter so much to you as a developer? Well, this approach naturally guides you toward writing cleaner, more modular code. You totally avoid the ambiguity of the diamond problem, which means your code is just plain safer and more predictable. You get all the flexibility you were looking for, but without any of the tangled complexity that multiple inheritance often brings. It's really the best of both worlds. And that leaves us with one last big question to think about. Swift made a very clear bet here, favoring composition with protocols over complex inheritance hierarchies. And as you go out and build your next app, it's worth asking yourself, is this focus on building objects from what they can do rather than just what they are the definitive path forward for creating truly flexible and safe code? It's definitely something to chew on. Thanks for tuning in.